Hello and welcome to 3.6 Derivatives of Inverse Functions. So today we're looking at the derivatives of some common inverse functions. One of the things we want to note is that inverse functions are symmetric about the line y equals x. Okay, a lot of times from algebra we've learned that for example xy would end up becoming yx in a function's inverse. Okay, and inverse, you guys will remember, is denoted by a little -1. It looks like an exponent, but it's not. It's just implying that that's our inverse. Okay, a couple things. If a function is continuous on the domain, then its inverse is continuous on its domain. Okay, if a function is differentiable on an interval containing c, and the derivative of c is not equal to 0, then the inverse is differentiable at f of c. Okay, now one of the interesting things I want to show you guys is if you have a function and its inverse. For example, in this diagram, 2, 3 corresponds to the point 3, 2 on the inverse function. Right? We just switched x with y. And then, well, the way the slopes work is if the slope is 4 on the original function, on the inverse function you get the reciprocal of that slope, okay, at the corresponding point. Okay, so at 2, 3, if the slope is 4, then at 3, 2 on the inverse, slope will be 1/4. Okay, and that's the special relationship between the slopes at corresponding points of function and inverse function. Okay, so let's work through this first example. It says let f of x equal 1/4 x cubed plus x minus 1. What's the value of the inverse function of x when x equals 3? Okay, well, let's figure out what happens. Let's see, what happens to our inverse function when x equals 3? So looking at our graphs here, let's do this graphically. If we have our original function, and here we have the original function in the dark, okay, notice the f here, and then here in the lighter gray we have f -1, that's our inverse function in the light gray. So they want to know what's the value of inverse function of x when x is 3. Okay, well, if you look at our inverse function, when x is 3, we end up with y value of 2. Okay, so 2 would be our answer for that. Now, what's the value of the slope of our inverse function when x is 3? Well, the slope of our inverse function when x is 3, okay, they gave us is 1/4. Okay, so that would be our answer for that one. Now, if we're going to use our formula up here, what we would do to get our 1/4 is we know what the slope is with the original function, right? Because if the y value is 2 for the inverse, that means that must be our point on our original function. So 2, 3. Okay, and now to get our slope of the inverse, we figure out what's the slope at 2 for our original function. Now, original function, let's take a look for the derivative of the original function. So we take the derivative, that would be 3/4 x squared plus 1, and then derivative of minus 1 is 0. Now plug in 2, so we have 3/4 of 2 squared plus 1. So that's 3/4 of 4 plus 1. 4's cancel. So we have 3 plus 1, so 4. So you know the slope of the corresponding point is 4. Right? The slope at 2, 3. Therefore, the slope at the inverse, you just flip it, it'll be 1/4. Okay. Okay, let f of x equal x squared and inverse of x equals square root of x. Okay, only for x is greater than 0, so only the right side of the parabola, if you picture the parabola, and then the top part of the parabola here. Show that the slopes of the graphs of function and inverse function are reciprocals at each of the following points. Okay, so at 2, 4, we have a point on our original function. We know the slope of x squared, the derivative formula of x squared will be 2x. And so if we do the derivative at 2 would be 2 times 2, which is 4. Okay, now let's take a look at the derivative of x square root of x. So derivative of square root of x would be, now this is going to be usually x to the 1/2. So when we take the derivative, this becomes 1/2 x to the negative 1/2, which means this will become 1/2 square root x. Okay, so if we plug 4 in to our inverse function derivative, so 1/2 times square root of 4. Square root of 4 is 2. 2 times 2 is 4, so 1/4. Okay. Now let's compare what happens at 3, 9, and 9, 3. So again, if we do the derivative of our x squared function, so for that one we would have plug in 3. We have 2 times 3, which is 6. And then our inverse, we have to plug in 9. And our derivative for the inverse is 1/2, and then plug in our 9. So that becomes square root of 9 is 3. 2 times 3 is 6. Okay, so our reciprocal relationship is true. Okay, as long as you're dealing with the corresponding points. Okay, and you'll always know the corresponding points, because if you have the original point of the function in the original function, the corresponding point in your inverse function, you always switch x with y. Okay, and that's always been the case with all of our inverses. Okay. Okay, so let's take a look at our inverse derivatives of our inverse trig functions. Okay, and here's a table. You guys should memorize these. You probably want to memorize at least the left side of this table. Okay, because you'll notice if you know the derivative of arc sine is u prime over the square root of 1 minus u squared, the derivative of arc cosine will just be the negative version of the same formula. Okay, and you'll notice that across the board. Arc cotangent is just going to be the negative version of the arc tangent. Okay, and arc cosecant derivative will be the negative version of the derivative of arc secant. Okay. Alright, so let's take a look at the derivatives of these inverse trig functions. Okay, so let's take the derivative of arc sine of 2x. So using that formula for arc sine, let's maybe bring that up again. Oh yeah, arc sine, arc tangent. Okay, so if we're using the formula arc sine of 2x, so here we go, it's u prime, so you're taking the derivative of 2x, which is 2, over the square root of 1 minus u squared, so 2x squared. Okay, so this ends up giving you 2 over square root of 1 minus 4x squared. Okay, so it's just a matter of plugging into the formula for it. Okay, so keep in mind, whatever's your argument here, that's your u. Right, so arc sine of u, arc tangent 3x is your u. Okay, let's do arc tangent of 3x. So now use the arc tan, derivative of the arc tan formula. So the top is the derivative of u, so we have 3. I'm going to do this out here. So I have 3 on top, and then for my bottom it's just 1 plus u squared, so 3x squared. So that gives us 3 over 1 plus 3x times 3x is 9x squared. Okay, and that would be it. Okay, arc sine square root of x. Okay, so let's do the work for that. Now remember, derivative of square root of x, we have to figure that out, which we did earlier. So we have x to the 1/2, and the derivative of it would be 1/2 x to the negative 1/2, which is the same as 1 over 2 square root of x. Okay, so arc sine, so we're back to arc sine. So this will be let's do this. We have derivative of square root of x, which is 1 over 2 square root x, and let's do times 1 over square root of 1 minus u squared. So the square root of x squared would just be x. Okay, and then what I could do then, I could write this as 1 over. Now if I were to distribute my square root of x into my square root here, that would just give me, my 2 would still be on the outside, square root of x minus x squared. Okay, and then you could just, because they're both square roots, you could just distribute that x into that second square root. Okay, so this will be the final answer for that. And then last one, derivative of the arc secant of e to the 2x. So arc secant, that's down here. Okay, so if we do this, that means in the top we have the derivative of e to the 2x. So derivative of e to the 2x would be e to the 2x times 2. So 2e to the 2x over, in the front of the square root you have the absolute value of e to the 2x, and then square root u squared. Now you have e to the 2x squared minus 1. Okay, simplify it. Absolute value e to the 2x is just e to the 2x square root, and then e to the 2x squared, you do a power rule, 2 times 2x, so you have e to the 4x minus 1. And then that would be it for that one. Okay, so let's take a derivative here. It says derivative that can be simplified. So let's see how we could simplify it. First, I'm going to rewrite my second piece to this. This is going to say x times 1 minus x squared to the 1/2, because I'm going to have to do a power product rule there. So derivative of arc sine of x, that would just be 1 over square root of 1 minus x squared. Right, because the derivative of x is 1. And we got 1 minus x squared. Okay, for the second part, we got the product rule. So it'll be x times the derivative of this expression. So that would be 1/2 times 1 minus x squared to the negative 1/2 times the derivative of the inside, which is negative 2x, plus 1 minus x squared to the 1/2 times the derivative of x, which is just 1. Okay, so now we have to simplify some things. So here we still have square root of 1 minus x squared on the bottom. Here, let's see if we can simplify this. We got this 1 minus x squared to negative 1/2. That's going to come down to the denominator as a 1 minus x squared to the positive 1/2. which is just a square root. Now this also happens to be a negative, right? We have negative times a positive, so that's going to make this sign become a minus. Now the 2 in the denominator and the 2 here, they'll cancel. And then we have an x times an x, that's x squared, so that'll be x squared on top. Okay, and then plus 1 minus x squared, and we could put it back in the square root. Okay, now let's take a look at what happens in these two pieces, because we could put this together as one fraction. They have the same denominator, so we have 1 minus x squared over square root of 1 minus x squared. So we could actually simplify this. These are the same base. If you want to think of it as base, you have a over the square root of a. So in other words, a over a to the 1/2. Okay, so then you could do like 2/2 over 1/2. So you're just left with a to the 1/2 then, if you're using quotient rule. Right, so for this one, this would just become square root of 1 minus x squared. And then you have another square root of 1 minus x squared. So altogether you have 2 square root of 1 minus x squared. Okay, so that's it for 3.6. Any questions, just email me. Have a good day. Have a good night. We'll see you soon.